Two questions about any random variable. Where is its center, and how spread out is it around that center? Those questions have names: expectation and variance. Roll a fair die over and over. What's the average result in the long run? Expectation answers that with a probability-weighted average. Sum up every possible value times how likely it is. For the die, that's 1 through 6, each weighted by 1/6. Add it up, and you get 3.5. Notice you can never actually roll a 3.5. It isn't an outcome at all. It's the long-run average across infinitely many rolls. One shortcut worth remembering: expectation is linear. E of A dash x plus b is just a times e of x plus b, no matter how x is distributed. Now, how spread out is x around that average? Variance answers that. It's the average squared distance from the mean. Expand that definition algebraically, and a handy shortcut falls out. Variance equals the expectation of x squared minus the square of the expectation of x. Much easier to compute in practice. Check it on the die. The expectation of x squared works out to about 15.17. Subtract 3.5 squared, 12.25, and the variance comes out to about 2.92. Take the square root, and the standard deviation is about 1.71, back in the same units as the die itself. So a typical roll lands about 1.7 from the mean of 3.5. Expectation is the probability-weighted center. Variance measures how far things typically stray from it. And standard deviation puts that spread back into real interpretable units.